Hello, Year 7, and welcome to the second week on physics. This week we're going to look at the topic of forces. So you will do similar to what you did last week. You're going to watch and listen to this video very carefully. You can pause it if you need to, rewind it. And then at the end, I'll give you more instructions on how to sign into Seneca Learning, and you're going to complete this week's assignment, which is on this topic of speed and forces. You should, it's quite a short topic, you should have some more time to go back through last week's assignment and try and improve your scores. More of that later on. Can I remind you that this video and any other videos that I recommend is on my YouTube channel, and I have a playlist for Year 7, NSB Year 7, so you'll find this video on there, and last week's just in case you missed any of that. So just a reminder, you might be familiar with some of these slides. We did these quite a while ago. Give you some examples of speed. Usain Bolt, we start with, can run 100 meters in 10 seconds. He could run a little bit faster than that, but it makes the math a lot easier if he's run it in 10 seconds exactly. Because you're going to use the formula, speed equals distance over time. You must remember that formula and be able to use it. So his average speed would be 100 meters in 10 seconds, which would be 10 meters per second. Why is it average? Because at the start he moves much slower. He has to accelerate to get his top speed, and when he crosses the line he'll actually be going a little bit faster than that. So his average speed is because his speed changes throughout the race. It increases or he accelerates. Another example is using this equation. Sound travels 1 kilometer in about 3 seconds. So from this you can work out the speed of sound. So using the equation, speed is distance over time. 1 kilometer is actually 1,000 meters. So put it into meters, divide by 3, and you get 333 meters per second, which is the speed of sound in air. And why do you see lightning before thunder? Because light travels much, much faster than that. It travels 300 million meters per second. So you see things before you hear them. Okay, if you needed to, in some of the tasks, you may need to rearrange this formula. And you can put it into a triangle. D at the top and S and T at the bottom. So if you cover over D, you get S times T, distance to speed times time. If you cover over S, you get distance over time, which is the equation you're given. And if you want to know the time, cover time, it's distance divided by speed. We looked at graphs, and if you look at a distance time graph, here's an example. If I just randomly show you somebody's motion, and we can describe that. So in the first 20 seconds, the line goes up from 0 to 10 meters. So they are traveling at a steady speed. 10 meters in 20 seconds would be half a meter per second. In the 20 to 40 second section, he travels no distance at all, so he's stationary. Then you can see the third section from 40 to 60 seconds. It's steeper line. Steeper line means a much faster, steady speed. The straight lines mean steady speed. And if the line comes backwards, goes down, then it means he's moving backwards. He will in fact go back to the start of the race or the start of his journey. On to relative motion. Can be quite confusing, so I'll just talk you through these slides. Imagine you're standing on the platform and a train is moving by 10 meters every 5 seconds. How fast is he moving? Well, use the speed of this distance over time equation. Be 10 meters divided by 5 seconds would be 2 meters per second. Now, the relative motion comes into the fact that imagine if you were walking as well, you were in motion. So if you were walking at 1 meter per second along the platform and the train is moving 2 meters per second, then relative to you, the train is only moving 1 meter per second. It's only moving 1 meter faster. So when you look at it, it appears only to be moving 1 meter per second, or 1 meter passes you every second. So it's a measure of how fast something is compared to something else. For example, a train moving at 2 meters per platform, it's also 1 meter per second relative to a walking person. It can sound confusing. Think about it. If you're sat in a train and the trains travel 25 meters per second, your relative motion at the railway line is 25 meters per second because you're on the train. However, you appear, if you look at the seats on the train, you appear not to be moving because you are moving the same speed as them. So your relative motion is 0 meters per second. So if you're moving in a train and all the blinds were down, it's blacked out, it was going at a steady speed and you couldn't feel anything, you feel like you're actually not moving. And that's what relative motion is about. Imagine now if the two trains are moving in opposite directions. So train A moving 3 meters per second in the left direction and train B 2 meters in the right direction, then relative to each other, they're actually moving 5 meters per second, because any point on the train in 1 second would move 5 meters. So it's 5 meters per second is our relative motion. This is explained in the Seneca Learning task again that you'll do at the end of this lesson. Moving on to the second topic of forces. A force is a push or a pull. It can change the way you move, can slow you down, speed you up, or change your direction. If no force acts, you will not speed up or slow down. And if you're stationary, you will stay stationary. So what force speeds you up when you're freewheeled down a hill? It is gravity. I'm not going to go on to these sections, it's explained in Seneca Learning, but the different forces can make you do these things, slowing you down, speeding you up, or changing your direction. So on to Seneca Learning. I have a good mark book from last week, and majority of you did really, really well. And some of you will be getting noted in that in this week's assembly. Look out for that. This week's assignment is on forces of motion. There are only 2 parts to it. Some of you thought that you only had to do one. You must move on, move through them. So set your task on speed and also on forces. It should not take you too long, about 10-15 minutes. Obviously, if you want to better your score, you can go on and spend more time on it and get a bigger score. And if your speed typing is too slow, remember you can adjust that with the arrow here. This is one I tried earlier. I obviously tried them out beforehand. I tried the speed one. You can see on the left, it keeps track of your progress. So for me, you can see that I completed the speed one when I took this screenshot. I did in 3 minutes, 10 seconds, and I answered 14 questions. If it was you, you would go on and do the speed one as well. I wanted to show you as well, though, I deliberately got one wrong, honest, and therefore I only got 96%. So if I want to get 100%, you can actually go back into it and you can then choose wrong answers only, and I can find where I went wrong and hopefully get it right this time, and it will appear as 100%. And it will appear that in my mark book as well. I want to show you what I can see. I've blanked out all the names. This is from last week on energy. I can see the percentage each person, this is in 7x, each person got on each section. I have sent some emails to boys to ask to do some more work, but most of you I was very, very pleased with. I can also see, again, blanked out names, how long you spent on each section, which is quite interesting. I will be sending emails out and reports of this and keep track of you as we go along. So hopefully, this week, you're going to aim to try and get 100%. Don't worry about how long it takes you. I'd rather see you get a higher percentage, but I will look to see that you spend adequate time on there. And I'm hoping that I'll get lots of 100% scores this week on the forces and the speeds topics. If you finish early, which I'm sure you will, please go back to last week's, have a look, see where you scored a low score. Try that again. This is a good way of improving your learning. So hopefully you enjoyed this video. Hopefully you're all well. Looking forward to the feedback that I'll see. And I'm working out how to do team sessions with small groups, which you will see. Keep an eye out for that. Goodbye.